I think we have
Okay, I
7.
think we have a quorum.
Yeah, we can start.
So, anybody tried any of these three competitions? We shortlisted any submissions or attempts?
Yeah, I tried the Airbus one,
Hmm.
and it looks quite good. I forgot the date. Wait, I can just share my screen.
Sure.
Just because there's couple of interesting things in the Airbus one, and then we can talk about the others too. Let me just share this guy. So the sub for now, I just I just down what I did is I just downloaded the output from one of the notebooks. I took this one. Um, is he using Fast AI?
Yeah,
Yeah,
that guy usually does. So.
yeah. And I could take the submission file and submit it. It ran really quick, like within less than a minute, and it was reproducible. So I did get this course.
Oh, wow.
Yeah, and so it's not a very high score. It's like in top 400 or something. But um, the one thing, oh wait, oops. The one thing I liked about oh, I just want to check the data set size.
29 gig.
20, oh, 29. Ah, okay, okay.
That's why I was a little hesitant, but let's talk
Yeah,
about the others. It's
yeah,
about close to 30 gigs, but it's good thing that at least you checked out that it works and it's kind of
yeah.
gives
Um,
feedback quickly, because 30 is
yeah,
significant, but not as big as the. I think the other one was like 45, and you needed data on top of it. So if it's only 29 and you don't need extra data, then it may not be terrible.
mhm. Yeah. So the reason I liked it is because we get to learn two things. I think so because so the ships can. So the goal is there might be you have to detect ships and put boxes around them.
Hmm.
Um, and they have to be aligned, so you can't have like a horizontal box here. Um,
Oh, so the orientation has to match.
mhm, yeah. Let me see if there's an example. Yeah. So the orient and the other nice thing is uh, there could be multiple ships in the image, or there may be no ships in the image.
Mm.
Right. Um, so what surprised me a little bit. So there are two parts. Right? So one is the just image segmentation, where each voxel you say ship or no ship, and there's some models for like object detection. So you just put a box around it. But so I thought people will be using the object detection models, but then a lot of people started using the segmentation models, which is the unit model I'm used to from medical imaging.
Mm-hmm.
And I used even this Mascar CNN before, so I was very surprised. Like they're using segmentation based, and these are like okay, let me get a non-top. Don't maybe uh, can I rank them by? Um, so oh, they had a leak. Oh, I didn't notice they had a leak in between. But okay, fine. I'll just pick one of them. Yeah. So see, this guy, he's talking about a solution without segmentation, right? So the people are so he's saying, okay, how I did it, but not using image segmentation, but just using. I think so. Even within object detection, there is a bunch of methods. So I think this one is called single shot detection. Yeah.
Yeah, there are these YOLO, if I
Mhm.
recall right. You only look once, and
Right. Right. Yeah. Um, did he put something? Okay. Yeah. There you go. So yeah, like you would put. I wonder if people are using segmentation because the ground truth has like a binary mask, but I'm not sure. Yeah, and then of course the other nice thing is the scale is like, the I didn't know, I don't see how the images were taken, but if they're taken at different orientations, the ship might be big or small. So your model has to learn like a scale, like um, yeah, and then what is this? Oh, wow, this is yeah. So okay, yeah, exactly. Rotation. So you want a rotation invariant detector, and you want a multi-scale um, rotated, yeah, bounding box method. That's okay. He's put some papers, but
Hmm.
um,
Hey,
yeah,
as you were scrolling, I saw something which caught my eye, and
yeah.
since that's kind of important, it said Kaggle resources not sufficient in one of the
Oh,
notebook postings. Can you search for that? And
sure. Uh, oh yeah, that's important. Okay, this one. Let's see. Yeah. Uh, okay, so this person couldn't cross maybe 0.69. Hmm. Did anybody, let me see if anybody says like how long they were training or, oh, I see they had a leak, so then they had to relaunch the competition probably. Yeah.
hmm,
Okay, let me just quickly see what, yeah, I know this one, blah, blah, UNet. Okay, so he used UNet with 384, no, blah, doesn't work. Um, there was a, okay, that might be for inference. There was a special prize for like, if you could get it to run fast. Do I wonder if he? Okay, I think that's just for inference. Like could you build a model that will like run very fast on the testing. Okay, so yeah, that was one. But yeah, if anybody else has the other competitions, we can. Um,
yeah, I tried, but unfortunately, I failed because I was too lazy to go through the whole thing, and it seemed like I tried the steel defect thing, but in order to get anything to run, I needed to do a bunch of work on. There wasn't maybe I was too quick and I didn't look hard enough at the various things available. But a couple of things I tried, it seemed like I would need to do quite a bit of work to get the thing to run successfully. So
okay.
frankly, I gave up too soon, I think. But between the steel and the salt, the one thing I saw was, there is a data difference. The steel is actually a little bit more. It's 2 gig versus The third one we had shortlisted was the Salt ID, which was only 445 megabyte. But one positive thing on the steel defect detection that I saw was it was much more recent. So it just finished like 6 months back.
Mm.
So that tended to, and it's not terribly big. 2 gig is something that I think you can still kind of
Right. Yeah.
do good enough job with. Hopefully, it isn't, going to take. I mean, it may still take time regardless of the data size, but
Okay.
that's the preference. If between those two, at least I was looking at, I would say, even though there is more data or it's a larger data
Mm.
size, I would prefer it just because it's a little more recent. So I'm sure that much of it um, is
Yeah.
not dated, whereas the Salt ID was from possibly 2 years back, I think. So a little bit more
Hmm.
Yeah,
dated, if you
I,
will.
I actually did the salt challenge when it was out. Yeah, so it was about 2 years ago.
Oh.
I ended up, yeah, like having to take the data out of Kaggle or whatever and process it. Um, at the time as well, I was using like Keras on it, so I ended up getting sort of stuck a bit with Keras. So
Oh, I see.
personally, I'd prefer not to do the salt one, but yeah, the steel one. If it's a newer competition and it's different, I'd prefer to do that.
Yeah. Yeah. I think.
Out of the two, anyway.
Yeah, the steel one sounds attractive because yeah, that small data set and yeah, more recent definitely sounds. And we would learn a lot too because I was just seeing what this person tried. So similarly, like he tried UNet and for segmentation, blah blah blah, and I don't know what FPN is. Um, he was able to do it with PyTorch. Um, oh, okay. I just want to see how long. Okay, so he has a 2080 Ti. Uh,
Yeah, so maybe you can, to just like that, maybe you can see search for Kaggle resources on this one to see whether
yeah.
anybody has complained.
Yeah. Kaggle. Okay, before 1 GPU a day. Okay, I don't have. Uh, yeah, you okay? Oh, I guess because I think the inference has. I think this one is like you have to run the inference in kernel only. So then you would do. Okay, I see that. I see why he's complaining. So because at a time in Kaggle you can only have one notebook, right?
Yeah, one interactive thing.
One
Right? Yeah.
interactive. I see.
Yeah.
So you can do training and then do inference after that. So I think
Yeah, but Colab is still free, and if
it's
Colab
called, yeah.
is if the data loading is not too much, then you can link your Google Drive to Colab, and that's a pretty good setup, easy enough to
Hmm.
do. Yeah, exactly
Yeah.
what this guy is talking about.
Right. Yeah.
So I tried I tried running very simple model here,
Uh-huh.
copying it.
You want to share your screen? I can.
No,
No.
I'll just send a link. Um,
Cool.
so what happened is format changed. They changed the input format. They previously file name and class were in one field.
Hmm.
So what I needed to do, I needed to add a field that basically was a combination of the two.
I see.
In order to run this notebook, but the only thing is I got like bad results running this. So like I think there might be some other things I needed to
Hmm.
change.
And you could make a submission.
That's that one I like. It ran all the way, and it ran through that sub.
So that submission dot.
Yeah.
Yeah.
But, let me see if I have it. Like I did it this morning.
I see. Cool. Thank you.
But he actually has like a couple. This notebook is it's sort of explanation of UNet, but it has it in with both with Keras and PyTorch.
Okay. So this, so you did. Okay, so we are detecting. I'll just quickly look. It's like detecting steel defects. So okay, you use segmentation and.
Yeah, and he in this notebook he because it's an illustration, he chose only class 4, so it's a very like easy. It's an easy problem to find like only one. He was looking for one defect.
Oh, okay. I see.
Instead of 4, so he.
Oh, so the images might have multiple defects.
I think it's 4 different defects.
Four different. Oh, I see. 4 different types. Oh, okay. Oh, that's interesting.
And it's an interesting how you basically because they look for for you to match the kind of the match defect, so they use the dice laws, and you have to pass in the pixels, and pixels are coded in the columns.
I see right here. Okay.
Yeah, so
Yeah.
it's a pixel and then number of pixels after that.
I see. Yeah, this is like this run length coding, right? So I forget how to read this. This was okay. So this is the number of pixels. Is this the position? Yeah, this is okay. And is it that it always confused me. Like, so if this is the position, then you go 1 pixel horizontally, or no, it's just a
vertically.
vector. Oh, vertically.
It's one vertically.
Okay.
And then from the next pixel, it's 4 pixels. From the next pixels, it's 6 pixels. I'm guessing that they're all on the same horizontal line. It's just like that crack is getting bigger.
Right. Yeah. Okay. Yeah. Yeah, I've seen that. Yeah, I've seen this format in so many competitions. Okay, now. Okay. Yeah, they just okay. Yeah, you basically do that. Yeah, you know what the shape is, so you make a mask, and then you just just loop through it and convert your vector into the mask.
Yeah, these kind of standard things are also learning, are also things to learn as you do these, I think. Like, so you become familiar with metrics that people use, like dice laws or Loess laws, and then also this run length encoding concept, and that helps too, I think, by going through these competitions. So Yuri, thanks. I think that just says at least this still works and is probably given Steve's comment as well. Maybe we can go with the choice of this one then as the next one.
Yeah. I'll just quickly see if I can. I guess I have to steal. Okay, yeah, it's only 6 months ago and lots of teams. Okay, I see.
And also, Mehul, while you are on the screen, you said you would. What's the way that you said you could pin the competition?
Oh, sure. Yeah, so you just click on compete, right? And suppose you will get a tab. You'll get the tabs, and say suppose something I hadn't pinned. So say I haven't pinned Jigsaw, right? So when you're away from it, it just shows the prize money. But when you hover on it, it will show you.
Oh, okay, I see.
And then once you pin it,
among the pinned ones.
Yeah, otherwise, yeah, you spend so much time looking.
Yeah, searching for it. Yeah, you have to hit search every time.
I really like this. Yeah. Okay, so I think they just say for the like I was trying to see if I could make a submission, then I just need to make a notebook, and the notebook click.
Maybe just to check that part, we can download the sample submission file and submit as it is.
Yeah, that's what I was just trying, but it won't let me. It says I need to make a, or
Oh,
maybe,
okay.
yeah, make a new notebook. And the
Yeah.
commit,
Do you need to enter the competition before you're allowed to submit?
I think I already entered it. Yeah. Wait, did I? Uh, hmm. Um, Can I make a new notebook and just add? Suppose I just did this and add. Come on.
Can you not just if you go to like one of the notebooks out of um, the list of notebooks in the competition, can you not just edit one of those and then you get the notebook and the submission with it?
Yeah, I'll try that. Yeah, I'm just going to try. I downloaded Yuri's submission, so I want to see if I can just add it as a data and
Right.
then submit it. But I'll try what you said too. No. Oh, no, fine. It doesn't. Huh. Okay. It froze on me. Okay, great. Wow. Okay.
By the way, I was trying to do something here, but because I was trying a couple of them this morning, now it says maximum interactive GPU sessions count of 1 reached. How do I find like where the like if I close all the notebooks, I should drop all the GPUs, right?
Right, I think so. Yeah. Okay, sorry, my Chrome is freezing. Maybe one of you want to try it. I can stop sharing and I don't know what happened. Okay. No. Okay, how about now? Um, no, don't restart. Okay, let me try one more. Okay, I'll try what Steve was suggesting. Let me compete, take one of the notebooks, pinned, steal notebooks. Okay, how do I okay, stop? Yeah, I think if you just stop it, it should release your file.
Thank you.
Yeah. This guy, copy and edit.
Has that one got a submission file on it? Yeah.
Sorry. I just saw it had a score. So.
All right.
Data or I don't know why it doesn't show me. Oh, I had to run it to create it. I thought it would already have it, right? Yeah.
Yeah, perhaps you need to commit it to actually to get your own version.
Oh, I think that's what Yuri was saying. Maybe they changed some format or something, right? Image ID, class ID changed.
Yeah, I'm sending a line that I needed to add.
Oh, okay. Okay, that's good. That'll save us time. Yeah. Can't I just make a? Okay.
But the only thing is so this is what training data, and I think I did the same thing for test data. But I'm not sure like that was all that's needed because my result was like, I think I got zeros. So.
Oh, but you could make a submission, so
That's the thing. It created. I don't know if it's created a file or not. It ran successfully to the end.
I see. Okay. I thought okay. Let's see. Output. Okay. Yeah. Okay, and then we can. Okay, I think we can play with this on our own and just see. But yeah, it looks quite interesting. The competition because pinned. Where is Steve still? What did? Yeah. Okay. Yeah, the unit is quite interesting. Like I can just show you in Yuri's file. So traditionally, right? It's called the unit because it's this U structure, and it came. The guys, like I was saying, they made it for medical imaging, and initially it's. Is it okay? I can just give a 5-minute overview of the unit. Yeah, like
Sure.
yeah. So there's a. Yeah, you basically you start with a single image and then it becomes thicker here because you take 64 filters. Then you downsample. So say you were at 512 and then you will come to 256. Yeah, this is new for me. Maybe this is different from the original unit. So I'll tell you this encoder idea, this pre-trained encoder idea. Yeah, this one. This is the original one. Oh, he used it in salt, salt detection. Yeah, I don't care. Where is unit? What? Yeah. Okay. Yeah. Yeah. So this is you basically take the input image. here, then you have 64 convolution filters, 64 convolution filters. Yeah, it is, yeah, they start with 572, and then I think because at they didn't do image padding, so and the filters are 3 by 3. So at every set of filters, you lose a size of 2, right? So 572 to 570, and then again 568, right? And then 568 they subsampled it, so you get to 284. And again, then 64 filters, so now 128, 128, and the same thing, 284 went down to 280. And then you basically keep increasing the number of filters till you've reached I think 1024. And the idea I've heard before is that uh, there's a small like 5-minute video from the inventor of the architecture. He said like when you go down this arm, it's like you're trying to say what is in the image, like is there a defect of type 1, 2, 3, or is there like is there a tumor there in the image, or so this arm is for figuring out what is in the image, and then this arm is for figuring out where it is. So here you are downsampling, and here the green arrows are you upsample again. And here there are some details here, like we started with 572, so in this figure it just shows up to 388. I think maybe there's a step missing, or there's some step to get back to your original image size. So you will get a segmentation map with ones and zeros, arrows, different. What else in this? Oh yeah, and this was, yeah, you have the down arms, the downward and the upward, where you up convolve, and you also have this side. So I never got a good intuitive understanding of this. You take you take your original input and give it back to. It's basically, I think they do, like when you look at the code, it's like a concatenation. But this will be interesting to figure out, like why this.
Those are the skip connections, aren't they? Is that what it showed in the other picture? Where, yeah, like sort of because of the fact in the encoder you're getting progressively smaller images, so you do the skip connections to keep the sort of detail going across as well as.
Yeah, I think that's what Steve mentioned is exactly what Jeremy tried to explain. I think there is a fast AI lecture where Jeremy kind of touches on it, and he exactly says what Steve alluded to, which is just like in ResNet connections, you provide the original because you're trying to rebuild the original image size. And by extrapolation or anything else you do, you kind of are blurring and or getting into other artifact issues. And the best way to recover is to provide the network the opportunity to learn the original image itself. So you kind of, the way that you're going down, you're compressing, you can think of, and coming up, you're decompressing. And the best way to decompress to be close to the original is to provide the original at that level, if you will.
Oh, I see. Okay.
That you had when you went down. So you kind of reusing the original, but compressed at that level to rebuild what you want on the way up. That's the way, at least intuitively, Jeremy was trying to explain what's going on.
Okay. Oh, that's interesting. Yeah, that helps. Yeah. So I think in the original ones, right? Like I remember doing this in the original ones. So yeah, we can call this the encoder and decoder, right? So in the original ones, you train the entire network from scratch. So you don't. But like even in Yuri's solution and in this one, yeah, they're using a pre-trained encoder, and I think it's even FastAI has a unit with a pre-trained encoder.
It does,
yeah, that's the ResNet basically,
The
on
ResNet,
the downside.
Yeah, that's where I got stuck when I did the salt challenge, because I was using like a UNet and Keras, and
Uh-huh.
it didn't have a pre-trained one.
I see.
Yeah, so I spent the whole competition trying to get a pre-trained UNet, whereas like Fast AI does have one straight out of the box.
Mm-hmm. Okay, nice. Yes. Okay. So okay. So most of you had. And else there was anything else in the unit? No, I think yeah, that should be. The crazy thing is how useful this. It's across how many domains this architecture is useful. It's like because like for example, like my company is a medical imaging company. We use unit so much. And I saw it used in the Kaggle competitions, like for medical imaging, and now in for like this steel detection. And I mean, it's not so complicated, right? It's a simple architecture.
What do
Can I
you?
ask you a question? What kind of images do you do?
We have MRI and some MRI and X-ray.
Oh, okay.
Yeah.
Well, okay. So first of all, I was able to submit.
Uh-huh.
I still have a bug, even with those two changes. Changing submission file was extra, and I think I still I still don't know transfer data probably into submission file, so I have all zeros. But I got like a score of 0.85,
Okay.
which is I think like I just guessed. I guess it
Okay.
matched
No,
zeros.
that's good. And yeah. Okay. So the score came quickly, so that's you didn't have to wait for an hour like.
No, it was kind of stuck, but then I clicked on different tabs, came back, and they showed up.
Okay, that's good.
What I want to ask is, so have you ever tried specifically with MRI? Have you guys looked at 3D at all, like a 3D unit?
Mm-hmm. We yeah, there's some 3D units too, and I think there's
I think it's by the same authors as UNet,
mhm.
and the papers are around the same time. But I don't know if like it's useful. People are using them. Is it useful at all? Or
Yeah, there are a couple. So and after unit, there's a newer one where wait, I'll try and find it. So unit was I think GitHub. Yeah, this is another open source. Um, where's the this is slightly different from unit, but yeah, it has the 3D segmentation capability. We we didn't try. Yeah, see, they have some 3D support. So this one, either NiftyNet or DeepMedic is quite good for just running 3D segmentations. It's not unit exactly. It's there's a paper here somewhere. Yeah, multi-scale. So that paper, yeah, this paper is very detailed. Like they changed the model a little bit. Yeah,
Mhm.
yeah,
Thanks.
yep. Yeah, so
Yeah.
this. Yeah, go ahead.
Yeah, I can tell you why I'm asking. So
Yeah.
I went to Penn State and I was judging Penn State AI competition
Uh-huh.
last few weeks, and yeah, so one group of students was proposing to be using
Yeah.
3D net, and it was interesting. I didn't know how useful it was, but they made it to the next phase, so I'm looking forward to see what they come up with.
What they come up with.
Cool. Totally unrelated, but I'm a fellow Neatly Line alumni as well.
Oh, when were you there?
84 to 6.
Okay, I was 93 to 99.
Okay. So I guess yeah, this competition looks pretty good. We can try it and see next week how much um, what where we get stuck or how yeah.
Okay, Sounds good. So let's kind of pick this one and
Yeah.
try and make some progress on
Yeah.
this. And for anybody who is new and would like help to get going and stuff, post your questions on the Slack channel and don't feel intimidated by people who are already submitting and stuff and so on.
Right.
The point is to help everybody kind of get to the next step in their learning. So it'd be more than people will comment and help you along on the process. So feel free to ask any questions. Don't feel reluctant to post any questions on the Slack channel.
Yeah. Thanks for the offer, Srinivas.
Thank you.
Okay.
Thanks, everyone.
Okay, sounds good. Let's do this one, try it, and reconvene next week. Then, unless anybody had anything else to add about this competition or. Okay, sounds good.
Yeah.
Looking forward to next week then.
Bye.
Thank you.
Thanks, everyone.
Thanks, Aaron. Goodbye.
Okay.
Bye.
See you next week.